Today we are going to take a look at prime factorization. So in order to do that, we need to know what factors and products and prime factorization is. So taking a look at what a factor is. A factor is those numbers that are multiplied together to get another number. So for example, factors of 6 are 2 and 3, or 1 and 6, because when you multiply them together, you get your other number, your 6 that you're looking for. Now, that product is that solution that's obtained when multiplying two factors together, which you learned about way back in elementary school. Prime factorization, on the other hand, is when we write a number as a product of its prime factors. Now I'm combining that term factor and that term product into a definition, and we're going to take a look at what exactly that means. The first method we're going to look at are factor trees, which you've probably learned about, and we are going to take a look at, and then I'm going to show you a different method that for some of you might be a little bit easier for you to use. So when we talk about a factor tree, we're breaking apart that number. So I've got 24, and I'm asking myself, what two numbers multiply together to get 24? Well, I say, hey, I can do 8 and 3. Now some of you might be going, I thought of 6 and 4, or I thought of 12 and 2. That's fine. The only thing we want to make sure is that the end of the factor tree looks the same. So then I look here and I say, hey, 3 is prime. So I'm going to circle it so I know that I'm at the end of my tree branch there and I don't need to go further. 8, on the other hand, can be divided into 4 and 2. And 2, prime. So therefore now I can go back again and say, well, 4 is divisible by 2 and 2, which I know both of them are prime, so therefore I have them. Now you cannot just leave your factor tree and say that's the prime factorization. We can write this out as 2 times 2 times 2 times 3. But if we get some of these numbers, when they get bigger, that are going to have a lot of them in there, I would rather shorten this up and write it in exponential form, which makes more sense, which we have 3 2's, so it's 2 to the third power times 3. So that is my prime factorization. Looking at the next one, the number 135, I know 135, that's divisible by 5. So if I take 135 and divide by 5, I get 27. And I know that because 5 goes into 120 times, because I get 20 nickels to $1, and 5 goes into 35 7 times. And then I add that together, and I get my 135. I know that 5 is prime. So now I keep and break apart 27. Well, I know 27 is 9 times 3, and 9 is not prime, but 3 is. 9 we can break into 3 and 3. So I see I'm at the end of my branch, and I see here that my prime factorization, I get 3 to the third power times 5. And I make sure that I have all primes in there. Now, the second method is going to be our ladder method, which I chose 124 because we already know how this one comes out. So I can go ahead and just show you my ladder method. And my ladder method, I draw a box and I divide out the smallest primes. I know that this is divisible by 2, and 24 divided by 2 gives me 12. It's like upside down division. Then I can divide out another 2 because I know 12 is divisible by 2, and I get 6. I know 6 is still divisible by 2, and that gives me 3. 3 I know is prime. And the awesome part here is that if I take my highlighter, 2 times 2 times 2 times 3 gives me my prime factorization. So then I can go ahead and write down that my prime factorization is 2 times 2 times 2 times 3, or also known as 2 to the third times 3. Now if we take a look at this next example, 132, I did something a little bit different so you could see. I'm going to divide out a 2. And I know that dividing by 2 gives me half of 100 is 50, half of 30 is 15, so I'm at 65, half of 2, so 66. Divide that out by 2, and I get 33. And I can see that 33 is divisible by 3, which gives me 11. Now I have a bigger prime here. So I end up with 2 to the second times 3 times 11. Now, I'm going to start these on the next video just so we don't go too long. So try them on your own and then we'll go ahead and do them together.